In this shot from 1950's Destination Moon, these stars were actually 2,000 light bulbs from car headlights. It was probably the most realistic portrayal of space at the time. But 68 years and several real-life space missions later, First Man used state-of-the-art LED screens to project realistic renders of the solar system and the moon's surface, even adding a reflection on Ryan Gosling's helmet. It took decades of technical breakthroughs to get to this point, from intricate wirework and robotic cameras to CG legs floating in zero gravity. Here's how space scenes have transformed over 120 years. Long before humankind took their first steps on the moon, filmmakers sought to bring their stories to space. In 1902's A Trip to the Moon, director Georges Méliès created the illusion of a capsule landing in the moon using a substitution splice, first shooting the actor playing the moon, then adding the capsule in another shot and combining the two frames. While this iconic shot is obviously fantastical, Destination Moon wanted to be as scientifically accurate as possible. However, the filmmakers had both a limited scientific understanding of space and a limited toolbox for special effects. In addition to using light bulbs for the stars in deep space, the cast also used a matte painting as a backdrop, with small cracks to create the illusion of perspective on the moon. But the biggest innovation at the time? Wires. To create the illusion of low gravity, director Irving Pitchell attached the actors to piano wire run through a pulley system and controlled by an overhead crane. This effectively lifted the actors off the ground, but keeping the wires from showing up on camera was a lot of work. According to writer Robert Heinlein, the set lights could make the wires visible on camera during filming. If the wires were seen in the take, they'd have to start all over again. The movie also wanted to show characters moving as the ship left Earth's orbit. To create the illusion of a person walking around all sides of the ship, the crew built the set with a fixed camera and 2 gimbals. That way, the camera could rotate in sync with the set. It was similar to the rig that allowed Fred Astaire to famously dance on walls in 1951's Royal Wedding. All of these innovations took a lot of time and money. As Heinlein wrote, realism is confoundedly expensive. Perhaps for that reason, space scenes throughout the 1950s and 1960s frequently relied on the audience's suspension of disbelief. Take this shot of a flying saucer in Plan 9 from Outer Space. It's clearly just a toy on a string. But that would all change drastically in 1968 with 2001: A Space Odyssey. Now that humans had actually gone to space, Stanley Kubrick needed to redefine what futuristic life in space would look like. And he did so by pushing the limits of visual effects. When it came to wires, Kubrick found that by simply placing the camera on the ground, the actors' bodies would naturally block the wires from view. But the zero-G illusions got much more elaborate. The team built a 38-foot-tall centrifuge that rotated at 3 miles per hour to imitate artificial gravity. Unlike the rotating set in Destination Moon, this one had 2 cameras, a mounted one that moved along with the set, and a dolly camera that moved with the actors. But not all the sets were gigantic. These models were much more detailed, elaborate, and closer to real NASA spacecraft at the time, thanks to Kubrick's famously obsessive attention to detail. To make the miniatures look like they were moving, the camera was driven along a track on a motorized mount around the models. This method made it possible to exactly repeat camera moves. The crew would do one pass of the Discovery, another pass of the stars, and then combine it all into one seamless shot. Kubrick basically created an early form of motion control cameras. And these new cameras revolutionized the space saga with Star Wars. With A New Hope, George Lucas wanted to create awe-inspiring space chases and battles. And audiences could be right in the action, thanks in part to a man named John Dykstra and his new camera called the Dykstraflex. The Dykstraflex was programmed by a computer to move around the miniatures in such a way to create the illusion of speeding through space. Like this imposing angle of the underbelly of a Star Destroyer, or this shot during the Death Star dogfight that appears to be from a pilot's point of view. The camera's precise programming also made shots easily repeatable for seamless compositing. It's why multiple models could be shot separately and then combined during the dogfight. It's also why the Death Star really looks like it's floating up in space, when in reality, this close-up was shot in a parking lot. Motion control cameras can be seen again and again in space movies. They were used in the Star Wars sequels throughout the 1980s and all the way through 2014 for the practical models of Interstellar. But all of these movies were about fictional space travel. Things needed to be a lot more realistic with Apollo 13.
Houston, we have a problem.
Oh boy, what's going on here? Flight, let me get back to you.
So director Ron Howard put the cast in actual zero-G for wider shots. It was the first movie ever shot on NASA's KC-135, where real astronauts trained for space conditions at the time. The plane flies up 35,000 feet in the air before plunging back to Earth. This renders all passengers weightless for 25 seconds. No wires needed. The crew only had 25 seconds per ride to shoot, so the filmmakers broke down each scene into small chunks, and then later used wires on set for close-ups. In total, the cast and crew took 612 flights, adding up to nearly 4 hours of weightlessness. Shooting on the Vomit Comet looks authentic, but the limited zero-G windows make it a logistical nightmare. And what do you do for shots that need to be much longer? Gravity contained harrowing continuous takes in space that lasted as long as 15 minutes, making it difficult to both move and light the actors properly.
We went to incredible lengths on the movie Gravity to portray microgravity or zero gravity.
First, the crew relied on pre-visualized animations that showed what the movie would look like before shooting took place. Studying hours of reference footage to create the digital characters also helped them imitate weightlessness more accurately.
People do not move slowly as though they're underwater in space. That's a common misconception. If you watch those astronauts, they move really quickly because there's no air resistance.
To tackle the sequence where a debris storm hits the characters, director Alfonso Cuarón and cinematographer Emmanuel Lubezki invented a new technology called a light box.
We were going to run for 15 minutes without a hard cut. We had to be able to plan the lighting and have perfect continuity because everything was going to need to sit together.
The light box built on existing technology. Sandra Bullock and George Clooney were strapped into tilt rigs while their space journey was captured by motion control cameras. All of that was inside a box covered with LED panels that could, for example, show real images of Earth from space as the backdrop. Because it was all programmed, they could change up the lighting faster than any normal studio light, which came in handy for the scene where they're hit by space debris. Movies like First Man built on the light box and went even further with LED screens. Director Damien Chazelle used a 35-foot tall, 65-foot wide LED screen to provide dynamic, 180-degree views of space in real time. That meant the Gemini space capsule leaving Earth could be captured in camera. And because this life-size model was motorized, the camera didn't need to fake any movements. You could even get this convincing lunar reflection on Ryan Gosling's helmet. Making the moon realistic took a lot of effort as well. Neil Armstrong's moonwalk was shot in a quarry at night that was manicured with gravel to replicate the moon's surface. Later, that footage was combined with real surface scans of the moon provided by NASA. It's the tiny details like this that really sold First Man. Look at this shot. The extra dust that clouds each footstep was added entirely with CG. And CGI might be the answer when it comes to truly mimicking zero-G movement.
Gravity is impossible to get away from. You're constantly under it.
Framestore made great strides in digital doubles in the midnight sky, making weightlessness look more real than ever before.
You hold your limb out and swing around, you kind of feel gravity doing its thing. We were able to completely eliminate that.
Digital doubles allowed filmmakers to conquer more challenging weightless scenes, like these wide shots of crew outside the Aether. This actor was minimally wired up on set, but his legs were swapped out with a digital pair, so there was no hint of real-world gravity. Fewer wires meant they didn't have to worry about where the camera was placed, as they did in Space Odyssey. The team also used a virtual camera system, where the cinematographer referenced an iPad showing rough animated footage. By pointing it around an empty room, he could physically block out the shots. This level of planning allowed the spacewalk to feature 70 fully CG performances.
The technology has come so far in the 10 years since we did Gravity that you can do these things in quite a lightweight way. And it is interactive and easy enough for a director to just hold an iPad and look around a set.
The result is a series of shots where digital movements, wire stunts, and even hidden crew members lifting objects into the air all contribute to make space travel both terrifying and awe-inspiring.
So we've come a long way since Apollo 13, and indeed we've come a long way since Gravity.
Méliès made a capsule fly so Kubrick could defy the laws of gravity, so Cuarón could capture the light of the solar system. Each might seem like a small step on its own, but taken all together, it was one giant leap for cinema, one dust cloud at a time.